Good morning, good afternoon, and good evening, everyone, depending on where you have joined. My name is Patty, and I will be your host today. First, I'd like to thank all of you for registering and taking the time to join us today for this webinar on Many Data Workloads, One Platform, Snowflake, a Modern Data Warehouse. But before I begin, I have a few housekeeping announcements. At any time during the webinar, please feel free to ask questions by typing them into the questions or chat window on your screen. Questions will be answered at the end of the session. Following the webinar, the recording will be available and shared with all attendees. If you experience any technical issues, please visit the Help menu in the GoToWebinar control panel on the right side of your screen. Lastly, I've placed all of you on mute to prevent any background noise. Now, to provide a quick background on Abstex, we provide customized IT consulting services for companies ranging from mid-size to Fortune 100 enterprises across a wide range of industry verticals. Leveraging agile practices, Abstex SMEs, subject matter experts, architects, and associates build software applications, platforms, and products that become primary drivers of innovation and revenue growth for our clients and their businesses. Abstex is recognized for driving quality and speed to market when business success depends on the software applications. Founded in 2007, Abstex is headquartered in Addison, Texas, with offices in USA, Middle East, and Hyderabad, India. Whether you're a business or technology professional, you may be looking for the performance, flexibility, and near infinite scalability to easily load, integrate, analyze, and securely share your data. Snowflake is a fully managed service that's simple to use and can power an unlimited number of concurrent workloads. It can be used as an ideal solution for data warehousing, data lakes, data engineering, and data science, providing secured sharing and consumption of data. The challenges that organizations face include how to use all the data existing within the organization and the complexity of building a self-adaptive data warehouse that is fully secured. Snowflake addresses these challenges by providing greater speed and agility, anticipate patterns faster, and optimize queries, importantly ensuring automated data organization with optimized workloads. The key takeaways from this particular webinar will be components and functional architecture required to build a complete data pipeline for both data at rest or in motion. Benefits of Snowflake compared to traditional data warehouses. How business use cases can be built for specific industry verticals on the Snowflake platform, and addressing organizational business plans to maximize revenues. Now, to introduce today's presenter, Sunil. Sunil works with us, and his functionality is an accomplished IT professional with 14 years experience. He has a record of excellence in analysis, design, development, maintenance, and documentation for various functionalities of data warehouse and data marts. Sunil takes pride in staying at the cutting edge of technical know-how. I will now hand it over to my colleague, Sunil. Sunil, the stage is now yours.
Thanks, Patty. Thanks a lot. Good morning and good evening, everyone. Thanks for joining our webinar. So most people are going to discuss on many data workloads on one platform, which is none other than Snowflake. Snowflake is a data processing which is made very simplified, and users can do data blending, analysis, and transformations against various types of data structures with a single language, which is nothing but SQL. Snowflake offers dynamic, scalable computing power, which charges based purely on usage, as like a completely cloud-based. So we have some takeaways here, which most firms don't turn data into actionables. So if your organization is truly data driven, like data first, actionable insights are the key to improve your product and operational process. All executive decisions should be based on data, and progressive companies today say that they want to be data driven, and Forrester reports that 70% of companies say this is a goal, although only 29% of these companies are actually successful in actioning their analytics. It's clear that the missing link for companies wanting to drive business outcomes from their data is actionable insights. uh, to cover some of actionable insights, like we can say that source, the missing link between data and business value. Then the key element will be the alignment. Insights that are closely tied with growth objectives are more likely to drive action. And context. Without context, our insights can spark confusion and lead to more questions than answers. And having the right context in place helps ensure that your insights results in action. And relevance of your data, or dealing with loading to get insights. And the last one would be, I can say, that clarity. If you don't fully understand the importance of insight, then it can become overlooked and forgotten. So these are the prime, some of the key insights which I can share. The evolution of data platforms, like say when we started, everyone has started with relational databases, like say Oracle, DB2, SQL Server. And then we have a different platform all to put together at 1990s. Where we have Teradata, which is nothing but appliances, and where we got into the system with the first MPP database, and then with a huge performance, and where we can deal with terabytes of data and petabytes of data. And it got resumed again, and then there were in 2000s, we have data warehouse platform softwares, like say we talk about Vertica, CleanFarm, Redshift, and Hadoop. Again, that's a good thing. And where we there were a lot of hiccups, like say that organizations only required to deal with the structured, why not unstructured? So that is the case. And we have progressed a lot in this, and then Hadoop got introduced. And the current situation, I can say that in a cloud native data warehouse, like say that example of Snowflake, where we have both the capabilities which is built on cloud, and then where we can deal with data warehouse platform, as well as where it deals with structured and then semi-structured data. So this agenda is going to be covered Snowflake overview, and when to consider Snowflake, and architecture deep dive, and benefits, use cases, and benchmarks. This is just an overview and then history. When Snowflake has started, they were found around 2012 by industry veterans, and there was a huge customers by now, which is over 3,000 active customers. And there are some fun facts about it, where we can point out in the last grid in the PPT, where is average queries processed per hour is 20 to 7 million, and the largest single table is 28 trillion rows, which is very huge, I can say. And single customer, most data, it was 7 petabytes. It's again a huge. This is just at a glance how the overview and then history was. And here comes our data challenges. Most part everyone faces this, say data diversity challenges. I can say that we have external data and multi-structured data and machine generated data, and we need to process these, which is external data and multi-structured data, into an platform where the data will sit permanently, and where we can do a lot of query and then do insight analytics, or even you do engineering or something to get some good insights out of it. And the another part is a complex data infrastructure. We have different data architectures, say based on depends, one may have EDW, which is enterprise data warehouse, and some may suffice with data marts. And now you have Hadoop and then NoSQL, which is complex systems, where we build based on the scenario and the data pipelines and data silos. And the barrier of analysis, I can say analysis limited to incomplete data, delay in access, performance limitations. So these are the challenges in which we are facing now. And apart from this, and there are few key challenges in our traditional data warehouse, like say inflexible structure. and complex architecture and slow performance or overdated old data technologies or lack of governance, which is our current challenges, and we'll see how we can you know uh, cancel these barriers and then move forward. Need to relevant the data warehouse, as I have kept here, it's a slogan is like a data warehouse for everyone. Like say you have all the platforms like say data warehouse performance and then enterprise capabilities and cloud elasticity and then agility and in mix of like a big data flexibility and scalability. So all keeping put together, I can say that Snowflake fitment is very nice, and the performance as well as even we have a flexibility of big data as well. Like say we can deal with data lake or like an even semi-structured data which we can deal and load the data on and like a cloud elasticity. Like and we know need to worry about the space or how queries or like and how the data is like and how scrambled the data is. So this can take care of like a need to relevant to data warehouse. Coming to the Snowflake elastic architecture data warehouse, see multi-elasticity where you can see here all new SQL data warehouse, no legacy code or no constraints, and delivered as a service, like no infrastructure knobs or like tuning the manage. And it is designed for the cloud as well as on-premise as well. I mean, coming and talking about the cloud, we can deploy it on AWS, Azure, and then GCP, any of the platforms, and bring together diverse data and loads into one system, and simplify and accelerate path from data to analytics, remove the cost and complexity for convenience, and then how we can deal with. And so these are some Snowflake differences and which will take, I'll say that when you talk about performance, multi-petabyte scale up to 200x faster performance and then 1/10 of the cost. And most part and where we'll be worried much on this performance, because there will be huge queries and you have concurrent users who will be simultaneously executing queries, and then there might be some degradation of performance or those things we don't have. And then any multiple any concurrent users can execute the queries and then get the results at the same time at the same fast and then with the proper performance. Simplicity fully managed with a pay-as-you-go model, works on any data. These are differences and how it makes from different from traditional data warehouses. So let's talk about architecture, which is multi-cluster and then sharing. So Snowflake architecture stands in such a way where you have multi-cluster shared data architecture where there will be three phases, which is cloud and then compute resources and then storage resources, which is one part, say that single integrated system. Snowflake Elastic Data Warehouse is the first SQL data warehouse built for the cloud. It's patent appending multiple cluster shared data architecture, physically separate storage and compute, taking full advantage of the flexibility of cloud infrastructure in ways that are impossible that traditional data and big data solutions where we can develop here. And Snowflake is a data warehouse service, and it makes possible for any of a centralized storage, the built for the cloud, and Snowflake like multiple parts, I can say that. And apart from this, it was a multi-cloud cluster, as there will be multiple nodes and where it will be clustered, and then Snowflake unique architecture also allows for extremely efficient data processing, because Snowflake is built to operate in multiple processing clusters that communicate in the cloud. And those clusters are all processing your analyst teams queries at once and scaling out as you are building up a database in Snowflake and preparing the database. And you can select the necessary capacity, like say that you want to go with a small, medium, large for based on the necessity again, and for your workloads to minimize processing efficiency while balancing cost and scaling up. You can even have Snowflake automatically expand and and contrast as necessary for the workloads. With these features, you will get insight faster than even before and without overloading your system. And specifically talking about multi-cluster, instead of having one large repository of data that manages all workloads at once, Snowflake partitions your data into different cluster, and the computer that can work simultaneously without affecting each other. And each cluster can work on the same data at the same time without any need of manual copying original data sets or like transforming the data. The data is shared in that multiple users can access the same data at any time throughout the day, and the changes are made available for the users nearly instantly. And Snowflake makes organizations wide access and effortless. Another beautiful part, like shared data and easily forge one-on-one, one-to-many, or many-to-many data sharing relationships. So your business units, subsidiaries, and partners like a securely query, read-only, or centralized data with perfect integrity from a single, always accurate data source. As I stated in another diagram here, like and it's a one platform and one copy, and which established. I mean, it will be a multi-cluster where the cluster will take care of the activity like based on the pipelines like in which we create, and secure and govern access all your data. We'll deep dive into this part in next session where how secured and how the data is governed in all the aspects. And there is a near zero maintenance as services, like in which is like in where we can deploy it on any of the cloud services, which is AWS, Azure, Google Cloud, or even on-premise, like where we can execute it. And then there is zero cost or zero maintenance, like I can say that, which where we can, to execute multiple queries or like concurrency or performance. So, these things will be taken care. And this is I can say Snowflake as an extension to semi-structured data. Like say you have semi-structured data as well as I mean the structured data as well, which is like and we can quickly load and transform and integrate any of the data like say JSON, Avro, XML, and other semi-structured data, which is like supported by Snowflake. And even it is like while on the go, like and where we have storage optimization plus query optimization, which will happen automatically, the transparent discovery and then storage optimization of repeated elements, and full database optimization for queries on semi-structured data, which once we load the data into the system. And the main part is here Snowflake architecture allows quick consolidation of all your diverse data into one platform, enabling analytics against large and broader data sets. The more you can execute analytics against consolidated, the more complex insights you can develop. Snowflake loads semi-structured data as an variant data type, enabling you to quickly query JSON in a fully relational manner with automatic storage optimization and query optimization, as I stated earlier. See, as you can see, scale on demand. There are pay for only what you use with no over provisioning, eliminate overbuy, and scale compute and up and down transparently and then automatically, and based on the loads, so we can scale up and scale down the cluster, and no need to do any capacity planning or something. So generally, if you talk, I mean, like in our traditional databases, so we need to do a capacity management based on the cluster which we build and the database size, like in which we do. And at the same time, there will be resources, I mean, assigned to and separate roles, like and who executes, like say a data engineer, database team, or some other XYZ teams, like and wherever we will have different roles assigned to a user, so that they can effectively raise the and execute the queries. But here it's not a problem, but where we can execute on the scale, and then we can execute a number of queries at the same time. And since it is Snowflake uses the cloud to enable elasticity. Here it's a multi-dimension elasticity I can which we are seeing at, and more of once let's say you have elastic scaling for storage, which is low cost storage and fully replicated and then resilient, and elastic scaling for compute, and a virtual warehouse scale up and scale down on the fly to support workloads, and elastic scaling for concurrency, scale currency concurrently using the independent virtual warehouses. So this multidimensional elasticity, unlike existing products, Snowflake elastic scaling technology makes it possible to dependently, scale users like data and workloads, and deliver optimal performance at any scale. And elastic scaling makes it possible to simultaneously load and query data, because every user and workload can have exactly the same resource needed, and without contention, and simple service of all business data. And Snowflake brings a native storage of semi-structured data, as well as here we can deal with and as you can see on the right side diagram, where you have different ETL pipelines where we do and then reporting ad hocing, and where we execute a number of queries, as well as data science team will have their own database, and marketing will have their own database, but there won't be any performance issues or something, where it will be elastic scaling on everything, all the aspects which we are talking about. One is on the storage, the another one is on compute, and the other one is on concurrency. And security and data protection, it's a prime area everyone talks about, and everyone is worried about. But what we have seen here is protection against data is virtually against protection against infrastructure failures. All data are transparently and synchronously replicated 3+ ways across independent on this infrastructure, because once you load the data, what happens is automatically it takes the data and then keeps the data into 3 replications, say into different infrastructure, say that you have a different node or something like that, node 1, node 2, node 3. Once you execute, there might be a data scattered, and then keeps data into multiple chunks, and then where it knows about the metadata, how to execute it. And for the production layer, again, protection against corruption or user address, there is an option called time travel feature enabled instant rollback to any point in time during choose and retention windows, which is possible, say that you have new data or modified data, or which is in the systems, those things, if something corruption or something happens, yes, you can roll back. And then there is this option is called time travel feature. And long-term data protection, this is another part. So we have loads on daily, weekly, and monthly basis, in which we run our loads and then they load the data. So long-term data protection, zero copy clone plus optional export to cloud object storage, enable user managed data copies. And you can connect to any of S3 bucket, or in any of Amazon services, or any of the cloud services, and load the data and keep the copy there. And if once the load is done, and which is not required, so that we can get the data from whenever it is required. And cross-region data replication, say business implications, multiple options for international customers, additional layer of protection against outages, and cross-cloud option for business continuity, and selective data replication support data, which is another requirements, say as you can see in the diagram, there was different regions, based on even any of the clouds you go, we need to select the region first, based on for fastness and the retrieval of the data, those things we consider. But in Snowflake, we don't have don't need to worry about any of these factors, like saying which region I need to keep the data, or how to access it. But completely, you may have different environments, say one can have US West can have an AWS, and then US East can have an Azure platform, and it can connect to any of the databases and then any of the cloud services and get the data, and replication happens simultaneously in the background. So this is a fully managed data platform as a service. As we can see, there are dynamically 3-layer service-oriented architecture as well. One is cloud services, or the collection of independent, scalable, fault-tolerant, stateless services, in which we can see in the first part, which is infrastructure management, query planning, and then optimization, and metadata management, then security, which will be taken care. And virtual warehouse are elastic compute engines that enable the execution of customer queries, like and which is in warehouses based on the workloads or like in a different database storages. Like and we may have different databases for different works or something. Like say that you have an one EDW and like you want to no need to touch EDW, or like and you can have a different data warehouse or data marts and then load the data uh, into the data warehouse, or like club them and then keep it into one place or something like that. Which one storage layer is like highly optimized columnar format, like which will take care of it and then loads the data and as fast as possible. And this is a modern data architecture where we can see we have different sources coming from the queues. Like say you have OLTP databases, you have enterprise applications, and third-party tools, or like web logs data, and IoT or anything. Like you have ETL, batch process, streaming, or whatever it is. Like whichever the data sources, yes, the platform supports, and where you can see this can be deployed on uh, any of a cloud, AWS, and then Azure. As I said, like many workloads on one platform. This is the real example which we can see here. Might someone have a data warehouse, and after that they want to build some data lake, and then yes, it is possible. And like even you have a data engineering team, and you want to give it another platform, so no need to go into another platform where we can build the same into a database and then start doing everyone. You can kickstart GitHub and then like create the environment for the same, and like an even with the data exchange, and which even we can build your perfect data apps for better insights, and then even data science, like everything into one goal, like and where we can see in one environment, which is Snowflake can take care of it. And the rest of we have to leave it. I mean, like which is like a data consumers data monetization, operational reporting, ad hoc analysis, and real-time analytics. Like most of the part, like and what we do is like and we store everything into database, which is like an in form of tables, and where we can query our data out of insights and then get ad hoc analysis, real-time analytics, and like even data monetization, which we can say. So here comes an actual traditional data architecture, like in which is complex, costly, and constrained. Like say we may have, as we previously seen in the slide, we have different sources, and which is like data coming from OLTP database, enterprise applications, third party, and all the data comes, and then we do an ETL and say that I have a data warehouse, now and then. Or I have an EDW, or like which is helping or pushing the data to data marts. Now, I might have a different uh, business scenario. Like say that, like, and I will have an integration and difficult and time consuming. Like say I have my data engineering team, like, and where they introduce Spark, and then where they have done some modeling, or like they have done some models executed, and then data has to come and then sit. Now I have an option here, which is like I can go ahead and then directly build a data lake here and load the data, whichever is like data modeling is done, and then like a data preparation, whatever it is. Then what I do is like I keep the data into the data lake, which is like a semi-structured format, generally how we follow in data lake. Whenever we require, we push the data, like say that on periodically, like in whichever is required. Like say that I require 1 year of data, so required, so I will pull only that 1 year data, so that rest of the data remains in your data lake, and that data will be pushed into the EDW, so that like I can optimize and get my actual insights instead of having all entire data into one EDW. The same way, if you want to build any of unable to ingest data to the scale, so this is another data lake which we will have, like any of the pipelines. Like I have built a data warehouse. Now I'm worried, like saying, I need to have another environment because like, and I have some unstructured data. Now, how do I deal with that? Like in the rest of the environments, we don't have this flexibility, or like, we need to do it in another tools, or like another premise, doing and scaling up, or like transformations, and then load the data into a system EDW, which is a very costly operation, I can say that. So that is the reason we have a data lake here, where we can ingest the data into a semi-structured way and then keep the data into the data lake. And the another one is governance and security risk, managing multiple copies of data. So this is another part, like where I may have EDW, which is like a huge, I don't need to execute, or like, and I have a different division, say in one division I have risk, and the another one is like an analytics, and then the third one is going to be inside team. So there were three teams like in which concurrently firing the queries. In such a cases, what I can do is I can take small data marts here and keep them, and then load the data into it. And coming to the security, I mean, like it is 24/7. Yes, like and it is secured over the pipe, whichever we load it, and we'll talk much on the security part and the multiple how to manage this multiple copies here. And the last one comes data consumer. As I said, limited performance and concurrency, but like in a Snowflake, we have an advantage with like where the resources will be taken on the same priority, and then everyone will have allocated on the same like space where they can execute it. And these are the traditional platforms, I mean, where we have infrastructure, we have physical design and query tuning, availability on maintenance. So these are the steps which we need to take. First, we set up our infrastructure, like initial setup, upgrading patches, and say that like you need to do one capacity planning, and storage and security, which first layer which we do. And again, once it is done, then we come to the physical layer. Whatever the data is loaded, like we should get the data in an very optimistic, and then like in a performance like which should not degrade, so that we do partitioning, indexing, ordering, and then vacuuming. And the third part is like the very huge part for everyone, which is stats collection and memory management, parallelism, query plan hinting, and workload management. These are the things like on how we a different window which we manage in our day-to-day activities. Like say that you execute one query, and then where it is running for a huge time, which like and we go for like do and collect stats, and then where exactly the problem is, or like and again you have to come back, and then you retune your query and then execute it. And that's how like and where we do. And availability and replication, again this is another factor where we need to replication, backups, reclustering, and all those things, and all is the huge mammoth task, I can say that. Like and once any of our loads, like say daily loads, weekly loads, and monthly loads, once they are done, we need to do a backup and keep it into one of disks or something like that, magnet disks, and or like even any of different location where we will keep. If something goes wrong, again we need to take the data from the backups and the load the data or something like that, where we keep some retention period for storing them. But coming to this, no infrastructure, no knobs, or tuning required. Say that first is infrastructure management, virtual hardware and then software managed by Snowflake, and even data storage, adaptive data distribution, automatic compression will happen, automatic optimization will happen, and metadata management, automatic collect stats will takes place, and collection, scaling, and redundancy, everything will happen. And there is a concept which we haven't heard, like, and which is we call it as an dynamic optimization and parallelization and concurrency management. And for coming to this, like there is a lot of optimization techniques like which happens on Snowflake cluster, like say micro partitioning and data clustering. So in traditional data warehouses rely on static partitioning of large tables to achieve acceptable performance and enable better scaling. In these systems, a partition is a unit of a management that is manipulated independently using specified DDL and syntax. However, static partitioner has a number of well-known limitations, such as maintenance overhead and then data skew, like and which can result in like say that like there might be some glitch or like size partitions. But like the micro partition will take care of it in contrast to data warehouse. In Snowflake data platform implements a powerful and unique form of partitioning called micro partitioning that delivers all the advantage of static partitioning without knowing the limitations, as well as like providing like in a very basic idea. I mean, we don't need to think like and by loading the data into the system. So automatically, once the data is in, automatically it takes in. So what are micro partitions? See, generally what happens is all data in Snowflake tables is automatically divided into micro partitions, which are contiguous units of storage. Each micro partition contains between 50 MB to 500 MB, which is configurable, and uncompressed data, I can say that. And these groups of rows and tables are mapped into individual micro partition organized in a columnar fashion. This size and structure allows extremely granular pruning of very large tables, which can be comprised of millions or even thousands of millions of micro partitions automatically, which happens in the background. And the range of values of each of the column, and like in which it will captured in the metadata, and like everywhere like where you execute it, automatically it gives back like and even it is in micro batches or micro partitions, which happens. And ideal benefits, I can say that there are in contrast of traditional static partitioning, Snowflake micro partitions are divided like an automatically. I mean, like, and we need to explicitly on upfront we need to mention them, or like maintained by user or something. It takes automatically. As the name suggests, micro partitions. I mean, as I said, like it divides everything into and like 50 MB or 500 MB, small batches. I mean, which is like packets, and then like it stores before the compression, and which enables extremely efficient DML and then fine graining, burning up fast of the queries, I can say that. And these are columns are stored independently with partitions, often referred to as columnar storage. And this enables efficient scaling of individual columns and store independent with micro partitions. And columns are also compressed individually within micro partitions. Snowflake automatically determines the most effective compression algorithm for the columns in each micro partition. And the another beautiful thing which I have seen in this optimization technique is called data clustering. Typically, the data stored in tables is stored, ordered, or along with natural dimensions. For example, you take an date and like geographical regions. This clustering is a key factor in unique, because table that is not sorted or is only partially sorted may impact query performance, particularly on very large tables. In Snowflake, your data is inserted, loaded into a table, and cluster metadata is collected and recorded of each micro partition created during the process. Snowflake then leverages this clustering information to avoid unnecessary scanning of micro partition during querying, and significantly accelerating the performance of queries that references these columns. And this is a best I can see, like say that a table consists 24 rows stored in across 4 micro partitions, which is a row divided equally between each micro partition. Within each micro partition, data is stored and then stored by the column, which enables Snowflake to perform the following. I mean, like say some of the actions, like which is like a first prune micro partitions that are not needed for the query, and then prune the column within the remaining micro partitions. So these are the two beautiful aspects like in which we have seen in our discovery, as well as like some of executing some of the customers. And coming to the benefits implementing Snowflake, the prime is like an organization by data driven culture, and team can concentrate on higher value tasks, because like generally what happens, like we take our traditional data warehouses, what we do is like, and we sit with the business and then like keep a business analyst who will dig into the system, and then he will understand the KPIs, load the data which need to be, and then again like, and there will be a data modeler coming into the picture who will do proper data modeling and then fitment with the data, I mean dimensions, facts, and then measures. Like again we need to define the fact tables, and again we need to give the measures like and how the calculation should be, and all those things. But now like we no need to worry about most of the aspects. We directly can load the data, which is like as I said, like some key elements we can take into data insights, and then like those are the 5 aspects which we can take, and then load the data and then see what best the data will give out of it. Enable worldwide use of analytical within the organization, as I explained earlier, like a worldwide. Yes, like say that like my one of my team sits in USA East zone, and then some sits on the West zone. So any of one like in the world they can use the same analytical platform, and they can access it while on a click or something. And new data sources, new services, and new sources of revenue. Say so this was a prime target for most of the customers. Like say now we have developed a data warehouse or data mart or like an EDW. Keeping in mind that like this is the fitment, and then where this is going to be the final version, but somehow after digging into like, and we got a new business, or we have a new structure or something. then in such a cases, like data warehouses, like, and we can't keep changing, and it should be, it's not that flexible to change in traditional warehouses. But here, yes, like it's nothing but like, and we can load the new data sources, and like, and we can have new services plug in, uh, and we can have some new source of revenues. And let me take an example here. Like, as we have built a customer, like, which is data warehouse, and then ultimately we got some semi-structured data, which is even unstructured data, I can say that. So what we have done is, like, there was some of the beautiful features, I can say. There is, like, APIs which we can integrate the data, and even we have Spark integrated system, as well as like any of big data, some of the aspects which we can access it, and everything is using APIs or like any of the connectors we have. And even Python is supported, where we can write our custom code in Python and then do the data. So in such scenario, what we have done is, we were able to load the data, and which is like an unstructured. We made it semi-structured and keep it into a data lake, and then like, and where we were able to get better insights. Business users gather insights with latest data. That's how, as I said, like, most of the business users gets insights with latest data. Like, say you may have the data now which is like old or something, and then like, and again you have to come up with like new dimension, or like something which need to be added again. It's a lot of uh, like man work, I mean, which is involved. Like, say that you need to create your scripts, and you need to see the business, like, and how it is going to, whether it will fit in your data model or not. These are the aspects like in which we generally look at while loading the data. But here, yes, like, and we can go ahead and then large scale or small scale, or any of the data we can fit in, which is new, and then we can get insights out of it. Build better applications, I mean analytical applications. Yes, based on this, like, we generally, whatever the data applications, or like the data which we landed into the data warehousing system. So these, like, we can use our any of the Power BI, like any of Tableau, or where we can build our data apps in it. And then, like, so there were, like, it's not limit, like, there were more options to explore. I mean, multiple uh, analytical services, like, say, we can plug in and then play. I mean, that's like, which is on a clicks way, where it don't take much time. And integrate with data lake, as I explained previously. We may have a data warehouse or something, but like, we don't want all the data to be keeping into the data warehouse, and then which will be messy. So that is a reason. So we can create another layer which is called data lake or something, and then stream the data whichever is coming, like, any of unstructured data, and then, like, make them sit into the data lake, and then some other time, like, whenever you require. So based on the pipelines we create, like, and we can pull the data and then keep it into the data warehouse for the better insights. So this will be the implementing benefits of Snowflake. And these are the common users, I mean, across the platform, like, say, data modernization, data warehouse modernization, and then replace legacy data warehouse with an elastic data warehouse as a service. As we may have a traditional data systems with an specified architecture or specified resources, as well as, like, space. So now we don't uh, you know uh, require all these glitches here. Like, it's, since it is an elastic data, we can load the data with, I mean, how much we require. BI acceleration, replace use of legacy data warehouse to drive more productive and then performant BI applications. As I said, yes, like, and we can plug into multiple virtualization tools, and then, like, and get better BI acceleration. And data analytics applications, which is like a providing a like reliable data warehouse to support various analytical use cases. And there was the another part which we can see here, like, and we can club, and then, like, and have a lot of I mean, say that, like, data lake, or like Hadoop alternative, I can say here. Like, you build a data lake, or like, and you do one streaming part, like in using Spark streaming or something, get the data and keep the data into data lake. And then, I can say, in this platform, we may not require complete Hadoop appliance or something, with very basic stacks, like, say that you have streaming, like, and we have a Spark API which we can plug in and then load the data and keep it into the layers, and replace use of Hadoop for, like, transformation SQL analytics of multi-structured data. Everything is which is pretty much possible in this industry verticals using Snowflake. And this is the case study, what we have seen, like say, when we are dealing with the customer, like, and where they have, event data coming from, and then internal data and third-party data, which is coming into the queue. And the customer had some problem, even they have some no database SQL, like, and which is a little tricky, like for doing some cleansing, normalizing, and transforming the data. So where we have kept staging layer, and where we transform the data and semi-structured format, which we have kept into the staging, and then pull the data into the EDW for further analysis. So coming to Snowflake, what we have done is like so the same data is coming up. What we have done is like we have introduced Kinesis, and like which pulls up, and then which is nothing but like a pull and get mechanism which happens in the Kinesis, like say that you have a packets which will be delivered, and then like we get the data. And we haven't seen any issues, like say that generally we will have like while dealing with any of Kinesis process, or like streaming process, there might be some network glitches in between, so that the data loss will happen. So generally it didn't happen, and then it was faster and then where in our analysis, and it was 50x faster data updates which we have seen, where we did cleans, normalize, and then data. Um, and we are able to load the data into an existing data warehouse, and then comparatively the previous process was taking us to 11 to 24 hours for like from starting to end, like from scratch, where you get the data to where we load the data to the UDW. But like and where in using Snowflake, we were able to complete everything in 15 to 30 minutes of work, like and where it was a lot of time reduction. I can say that more than 50% of the time which we have reduced, and nearly limited pipeline failures again, able to retain full data granularity again, along with data quality. And this is another use case where like the customer benchmarking which we have done. There is a marketing research company which has come with business case, like saying they want to replace on-premise data warehouse with Snowflake for analytical workloading. So where we have seen a data warehouse appliance, like and which took 7 hours for us to do and replace on-premise data warehouse with Snowflake for analytical workload. And where we have seen in the Snowflake, it was just 26 minutes. We are able to research it, and then like make an replace on-premise with data warehouse with Snowflake. And another part like which we have done in telco, which is improved performance while adding new workloads as a fraction of the cost. So what has happened is like we had data warehouse, which is an appliance which is in-house, and then where there were more of merger and acquisition concept, I can say here, which we have implemented here. So we all put together, the customer got a new complete data warehouse, like and where we need to include into. And it didn't take much time or like huge money to be rolled. What we have done is like it was just in few new workloads which we have added, and then loaded the new data warehouse data into the bucket, and like and where we was able to suffice the actual problem with a telco customer. The another one is like in the gaming company which we have executed, which is like a replacing of NoSQL data stored with Snowflake for storing and transforming event data. So as I said, the NoSQL data, like we have the customer was struggling to load the data, which is some cases it was like semi-structured, and then some it was like completely unstructured. So we took two buckets, which is completely unstructured. We have filtered out, and then like where we have done a different pipeline. And for structured, semi-structured, we have created one pipeline where we have loaded this data into two buckets, and ultimately we're able to load the data into one single bucket ultimately, and then all put together, like and we're able to create one more Snowflake warehouse here, like in which we have built, and which again like it was almost, I can say that less than 10-15 minutes, like and where we were able to just with 10-15 records which we have tested here. But only thing is this use case, whether it works or not, that is the main thing which we have concluded here. But yes, it is working. And so finally, why consider Snowflake and zero maintenance? Generally, if you have a look at this, so here Snowflake is taking care of complete vendor, as you see. most of the part, like infrastructure, we are not doing data center hardware and then software and scaling, which is not doing all the things will be taken care by vendor. Here comes the actual pain areas, like in our database management and tuning. So index management is the prime. Generally, once we load the data, we do a proper indexing for retrieval, and data partitioning is required, and method and static maintenance is required, and query optimization is required. So generally, we may have cross joins, like which we have implemented. Some see depends again, like you may have 10 or $12 developers, like depends on his skill and then like an experience. He may end up writing some different queries, so that like the query optimization is required. So even this part, like we don't need to worry, which is taken care by Snowflake, and automatically it takes, as I said to you, like there is a concept which we discussed, like a micro partitioning and then like a clustering, which will take care of it, and then your query optimization will happen. And the main part is data service and protection, which we do, I mean, which is like a failure recovery and then disaster recovery and data protection, and like service monitoring and then other things. So this is another very pain area for most of us, like which we are dealing now. Like say any failure happens, like we need to go run behind the recovery team and then like check whether they have the copy again, copying it and then like keeping and into actual location, and like this is again we need to do an uh, reloading of the data, and again data protection we are talking about. So there were a lot of data protection plans, which is like continuous data protection plan, which is taken care by Snowflake, which is it encompasses a comprehensive set of features that help protect data stored in Snowflake against human error and like malicious acts and even software or hardware failures at every stage within the data life cycle. And the Snowflake enables your data to be accessible and recoverable in the event of accidental or international modification or removal or corruption. There were pretty much a lot of data protection things has been taken care, like even access and the control, like security roles and controlling user access and data inscription and Snowflake time travel and then false safe, which were talked about. And these are the prime aspects I can say, that like rest of we have to deal with the customer, as like you can go with the cloud hosted with EDW with rest of cloud services. But like in the Snowflake, we have seen everything taken care of. So only thing is we load the data into the buckets, and like we will have our own uh, data to be like much time where we can spend on having better insights. And yeah, I hope I was able to explain distinct advantages using Snowflake and value add services which brings to the table and compressed to your on-prem data warehouses. And I would like to take a pause and move to a Q&A if any questions, if you would have.
Thank you, Sunil. That was very insightful. At this time, as Sunil said, I'd like to remind all the attendees to, if you have any questions, to do so by typing them into the Q&A window on your screen. Thank you. Does anyone have any questions or possibly clarifications or additional comments that you'd like to make? Sunil, would you like to highlight anything further that you said during your presentation and at closing?
See, I can see some questions. I mean, if you have anything like you can point out, or else like I'm good with that.
I don't see the questions actually.
Ah, okay, great. Or you can take the questions if any, or like and we can mail them or like and get in touch after the session or something like that. Even that is also possible.
What would be the technical use case for a customer who is optimizing and migrating from one process to another when using Snowflake?
Okay, is it? Can you please repeat it again?
What would be
Mhm.
the customers when they are transferring or optimizing when using Snowflake?
Okay,
The
so
user, if you will. We'll
yeah,
predicate
so
that
see,
to the user.
right. See, if you're talking about optimizing, most part like and we
Mhm.
are not going to see as we can see in traditional databases. Yes, there are multiple things. I mean, which we can take care, which is creating materialized views, and then as much as like in a database we can use everything, but like these are the system given like which is as I mentioned earlier, like which is partitioning and all those things. I mean, which is clustering and then micro partitions.
Are there any further questions that we have from the audience today? Okay, I'm waiting for some more questions and I don't see any. So I believe that we will be sharing this particular webinar, as mentioned before, in order to help clarify anything that you may have, if you will. Or if you want to ask any questions that during the webinar you may not have had the opportunity, or you simply were not thinking about that, it might be a good idea for you to do that. Here's one question that I have. Does Snowflake replace, or shall I say complement, a data lake, if you will? That's a question.
Okay. Can you please repeat it again?
Of course. Does Snowflake replace, or shall I say complement, a data lake?
Yeah, see, that's the right question. See, what happens is it's just an add-on to the data warehouse. Generally, what happens is like once you have any of the data warehouse built, so generally we can't deal with any semi-structured data. So that is the reason like in where we have the add-on, as I can say that data lake to Snowflake. Like say not all the time, or like not all the environments, like, and I can say that like we can deal with semi-structured, like say Jason, I have seen some examples, like say loading with any compressed, like say that you may have excellent JSON, but rest of the formats I haven't seen. But like you have a different approach here, which is like we can deal with Avro, Parquet, and then even with the compressed, which is like snappy, where we have loaded. I mean, like say 1 terabyte of data, like where we have seen in less than 15 minutes. I mean, again, it's a very small cluster, just to test and then see the benchmarking which we have seen. Yes, it's just an add-on, I can say that. Usually data lakes are usually considered a complementary solution to data warehouse.
And in the sake of time, I have another question. If we do not have a data lake implemented, how will Snowflake handle unstructured data, Sunil?
Okay, so these are the two entities, frankly speaking. Say you don't have any data lake implemented. Yes, we can straight away go ahead and then create a data lake and load the data into, primarily into a data lake on a, once it is semi-structured or something. Yes, you can keep it directly, structured, or even you can keep the semi-structured data into the data lake, and then where we can connect the same database to our data warehouse, which is possible.
Thank you, Sunil. That's all the time that we do have today. However, if there are any questions that we didn't get to, we will share the answers along with the recording of this webinar. You may also email us at any time at info@appstechcorp.com, and that's info@appstechcorp.com. Thank you, everyone, for joining us for today's webinar, and wish you all the great day ahead. Thank you kindly.
Thank you. Thanks, everyone.
Thank you.